Hello everyone. In the last class we discussed about need of SVC and StatCom in our systems. Now let us focus on each of the components. Very first one is TCR, already covered. We have completed in previous videos. Now let me explain the TSC, Thyristor switched capacitor. The power circuit of TSC as shown here, figure A. A capacitor is connected in series with anti-parallel combination of thyristors and in series with small inductor to limit the current as shown in figure. V is the voltage across TSC, current I is the current flowing through it, whereas Vc is the voltage across capacitance, VSW is the voltage across thyristor switch, and VL is the voltage across inductor. In the right side figure, the voltage and current waveforms of TSC as shown on the top figure. When thyristor is switched on, the voltage waveform as shown here, and the current waveform is 90 degrees leading with the voltage waveform, and the voltage across VL is approximately 0. And the voltage across the capacitance when thyristor is switched on is shown the negative at the negative peak as shown in the top figure of the right side, and the bottom figure shows when TSC is on, switched on, the voltage is 0. Across the switch, thyristor switch. When TSC is off, the voltage across the thyristor switch is equal to supply voltage. And the resonance condition is given by root XC by XL. Hence XL is very small value compared to XC. Now let me explain the transient free switching of the TSC. Vc is the voltage across capacitance of TSC, and I is the current through it when thyristor is switched on. And the quality factor is given by Q is equal to R by omega L, that is 5. In the figure A, TSC is on at VC is equal to positive maximum value. In the figure B, when positive maximum value, TSC is on. Now the current is flowing 90 degrees leading with the voltage. Similarly, in figure B, TSC is on at negative maximum. In that case also, the current is leading with the voltage as shown in the figure. Now let me explain the capacitor when it is fully discharged in figure A. And the capacitor is discharged with 0.5, 50% in figure B. When the capacitor is fully discharged, the harmonics have been shown, and when the capacitor is discharged with 50%, then the transients are shown in the figure. For transient phase switching, the difference between the capacitor discharge voltage and supply voltage must be minimum value. Suppose when let us have case 1. In case 1, VC capacitor voltage is less than or equal to supply voltage. Then switch on the TSC at its positive peak value, that is V. Then it is VC is equal to V. That is, voltage across the switch is equal to 0. In that case, the transients in the TSC are said to be minimum. When the voltage across the switch is 0, it won't lead to any transients. In case 2, VC capacitor voltage is greater than supply voltage V. Then we can switch on the capacitance at alpha is equal to 0. Alpha is 0 is corresponding to peak value, and the capacitor voltage is higher than the maximum value, and hence the voltage across the switch is capacitor voltage minus peak voltage. It is a minimum value, minimum possible value, in order to reduce the switching transients of the TSC. operating characteristics of the TSC are shown in the figure, in which x-axis is the current, y-axis is the voltage across the TSC, and BC is the susceptance of the TSC, is given by VC max into IC max. In fact, BC is equal to BC into VC max is equal to IC max. BC is equal to IC max by VC max. That is the correct equation related to TSC. Now, during straight line only it will operate, generally at its maximum value. I max is equal to IC max is equal to VC max into BL max. It is a straight line and linear. So therefore, it is possible to have the positive, that is leading reactive power control with the help of TSCs. You can have the step-like changes in reactive power plus Q, plus Q1, plus Q2, plus Q3, like that. When TSC1 is on, plus Q1, TSC2 is on, plus Q2, and TSC3 on, plus Q3. Like that you can have the switching operation of TSCs. So by having the switching operations in a transient free manner, you can reduce the overall harmonics injected by SVC with the help of TSC, TCR type SVC. So in TSC, TCR type SVC operation, so you need to operate TSCs in a transient free manner and TCR in minimal harmonic injected mode to the system, so that you can gain the maximum benefits out of SVC. Thank you.